We thought we'd give you an idea of what it's like from the crew perspective of the mission, so that we first thought we'd do an interpretive dance. But after a few rehearsals, it didn't go so well, so we decided not to do that one. So, and if a picture's worth 1,000 words, well, we got a video, so that should be a few million. So we're going to narrate the video for you and hope you enjoy it. So in March 26 in Baikonur, Sasha, Oleg, and I were getting ready for launch. We reported to the commission. About 2.5 hours prior, we got up the ride to get on the rocket, and at 3 in the morning we launched. It was a great ride. The first stage is a little different than the shuttle. It starts off with not the same amount of thrust, so you can feel the side acceleration as it goes off. There's a 3-stage rocket. You can feel each of the different stages as the one stops, the next one continues. I enjoyed it very much. As you can tell, we can tell Sasha is the commander. He's got the pointer. His first stage separation, you can see from that, it was a beautiful night out. And after about 8 minutes and 52 seconds, main engine cut off. We were quite happy at that moment. And about 4 hours later, we were not so happy when we had a failure in the system that turned us from a 4-orbit rendezvous to 52 hours on board before docking. And my iPod wasn't working. But luckily, our rendezvous went smoothly from then on. It is all automated. However, Sasha was ready to take over at any time. I'm not sure, you probably would have done better, wouldn't you, Sasha? I think you would have. But the automated system did well. We docked to the MEM-2 part of the Russian segment. And after a couple hours of leak checks, making sure everything was good to go, we opened the hatches and came on in and started for Expedition 39. Rika, Koichi, and Misha were on board at that time. And, well, we had fun. He said there are many ways to translate through station. The best way is doing flips. I think I do hold the record, at least in my mind, for how many flips you can do before hitting a wall. We did many science experiments, however, we also had to do lots of maintenance on board. Here's a rack I had to work on, and it's interesting, I think, to note the size of this rack, and then compare it to, it's all on all 4 sides is that same size, so it shows you the real volume of the space station. This is not a car engine, it's a carbon dioxide removal device. Yeah, it's hooking up some of the veggie for to grow plants later. That's that same device. We had to take this completely apart, which we enjoyed. I also became an expert on the toilet, so my new career, I think, will be in that industry. Here's a view of the lab. It just kind of gives you an idea of how busy the walls and ceiling and everything are in the lab. There are many, many different laptops and wires that run all the experiments. And even after 6 months, I think I knew where most of them went. We also had to maintain the suits, keep them in shape for our spacewalks. One of the first events we had while on 39 was SpaceX arriving. It's a great cargo vehicle. But the big advantage, of course, of SpaceX is we can put our supplies and science back in it and have it return to Earth safely. And hopefully someday we'll have people on that doing the same thing. The way this works coming in, it will fly with about 10 meters or so of station. It will then hold there where we take the robotic arm and grapple it, and then the ground controllers will then move it on into a position to berth it. Once it's berthed, it's unloading it, performing all the science. We stay on station for about 30 days. And once that's complete, we'll load it back up once again with all the stuff to head back to the ground. It is a little easier to move large objects in space. Of course, a little more difficult to tackle. We did have a computer fail while we were on board for 39, so we were not too disappointed because we had to go outside. And Koichi had the hardest job here. It took us 5 hours to get us ready for an hour and a half spacewalk. But there were no issues on the spacewalk. It seemed to go smoothly. However, I did hear that that same computer had a power fail about 4 or 5 days ago or so. But it powered back up fine, so it wasn't our fault. Rick and I had a great time on this short EVA, though. We enjoyed it tremendously. We made sure we had a lot of time for pictures. So now I think I have 2 claims to fame for EVA. One is I did an EVA in all 3 hut sizes, which I don't know is good or not. It's not that I changed that it's big in size. And the second is one of the pictures was used on Jimmy Fallon. That's pretty much that's it.
Then in May, right at the end of May 28th, Alex, Max, and myself would head up to the space station. That's me saying goodbye to my 2 girls. Definitely the hardest part of spaceflight was saying goodbye to the family. And we're off and we're underway. I think this is a main engine cutout, which you can see is a pretty dynamic event. And then it takes a couple seconds to recage your brain that you're actually floating, especially Alex and I are both rookies. And then there's that euphoria of surviving ascent. You can tell by the look on our face we're having fun. That's one of my kids' toys there, Giraffity, our weightless indicator. And then, the view outside is just better than you could ever imagine on that first look out the Soyuz window. And then for us, we were lucky enough to do a 4-orbit rendezvous, so it was only about 6 hours after takeoff. We were already up on the space station. And that's a crazy first couple days. You think it would be this magical floating experience, but in the end, it's actually pretty difficult. And then the boring part started. And so as we got up there, we joined Sasha Oleg and Swanee and began Expedition 40.
The next cargo vehicle to come up was a Cygnus. And if you notice clearly by this one, it doesn't have an issue right after launch. So it actually got to us, which we were very happy about. And this had quite a bit of cargo for us. Got the garbage truck here, and we let it go. And once we let it go, it goes up to the ground station, as you'll see. And then 2 days later, we will fly over it as it re-enters Earth and burns up.
And then this segment will be all about the science. That's really what we're up there to do, is to, when you remove gravity from a situation, weird things happen. So we would spend at least 5 hours a day, each crew member, working on the science up there, talking directly with the investigators on the ground, a lot of times using video and doing the research. So this is some stuff for MIT, working on Sphere's autonomous satellites, and these guys were flying formation off each other just using electromagnetic forces. And we even had this a vision set for it. We could hook a smartphone up. Swanee grew some lettuce while we were up there, and it also worked as a good nightclub in Columbus. There's a beautiful romaine that Swanee grew, And we weren't allowed to eat it, but it was delicious.
That one's about fluid science, which is one of the most surprising things in orbit is how fluids behave, and you can learn a lot actually for industrial processes up there by investigating it. Reed did a lot of burning science, which is amazing because you can study combustion in a way that you cannot study it down on Earth. And one of my favorite videos at all is like the jellyfish flame, and it looks funny, but it's actually very relevant for future combustion engines, car engines, and all that. So this is another one that we burn materials in space for creating safer spacecraft in the future, and also safer, fire-safe materials on Earth. So it's always fun to learn things, especially in space. Here, I think I'm cranking up a little device for immune system research. It has lots of different experiments inside that you just activate and deactivate after the flight, and then scientists read them out down on the ground. Reed was doing a lot of material science, looking at colloidals, also very important for industrial processes, while Swanee tried to slice his leg in pieces. Luckily, even though it looks like he could do that with that device, it's only for ultrasound. Studying how muscles decay in space, which gives us a lot of interesting data on how muscle atrophy works on the ground, because we have like a simulated one in space that we can look at and recover. We look at our eyes. In this case, we have with some people in space change of eyeball, and we look at how that happens and then how we can prevent it in the future. A lot of samples we store in a cold freezer, minus 80 Celsius freezer. It's really hard to get stuff in there because it's kind of frozen solid. It's easy that stuff floats out because you don't see anything. You can see a Reed blowing away the fog there, so you can see what's inside there. So lots of science, but once in a while, like after hours, you have a few minutes a day where you can just look out the window and enjoy how beautiful it is. These images are time lapses, so we set up cameras once a second to take a picture, and then we convert it into a video afterwards. And some of the things you see is so amazing, especially for me as a geophysicist. I was first happy to see that Earth was actually round. And then look at the atmosphere. Even though I thought I understood it before and I knew it all, I mean, it completely surprised me when I saw this for the first time. Images at night, seeing the flashes, I mean, hundreds of flashes a minute over the tropics. Some of the flashes were so bright that they actually lit up the hull of the space station. You can see the hull being bright just by flying above the lightning flash. Atmosphere really, really thin, incredibly. And we could have spent hours and hours and hours looking out there. Flying above the Sahara, you could always tell when nose 3 got red inside, orange inside. You could tell you were above the Sahara without actually looking out the window. It's just incredible. And some of those images are actually science itself, especially the ones where you can see the atmosphere, and we turn the aurora pictures into georeference pictures that scientists use for figuring out how our Earth's magnetic field protects us, especially in the future from magnetic storms. So even that, some people have told me there was an orange on this picture, but I've never figured out where it was. And that's kind of showing how Reed and I had our coffee routine every day. One of us would brew up the coffee and throw it in the direction of the other person and just give a 3-second warning saying, hands out. And if they don't react, then they can get slapped by a hot coffee. And that's the way like you deal with food, especially when you want to dig for your favorite candy bars. The back are non-existent in the box. And you now see why you have so much stuff in there that you don't ever pull out.
Nice.
A few glasses when you tell us towards the end of the increment. Every time I tell a story, it's one more, so I think we're at 18 in the last 5 weeks. And this is actually how you brew up food. One of the methods is to have dehydrated food. You just pump hot water in there and net it a while, and it actually tastes surprisingly well for some of the dishes. Some don't. So this one, I think it's breakfast. Like I figured out, tells you something. But the veggies actually came out quite nice. And this is every night we would sit there and eat together and talk about what we eat today. It's probably very similar to what we ate yesterday. But then the first 3 months is actually quite nice because you try different foods, and then after a while you kind of get look forward to a barbecue around. It's only trying to juggle. It's actually surprisingly difficult to juggle in space. It's harder than on ground. Tony was the expert in there. Reed was almost as good, and I didn't film myself because I was a complete disaster. We had more success in the soccer band. All right, I'll turn over to Tony here for the exercise.
We would exercise for over 2 hours every day. There are 3 major devices. This is called ARED, which is kind of like lifting weights. We had a treadmill. You can see the harness that holds you down. It wouldn't work so well without it. And it made running a little different, that's for sure. You're a little light around your feet, but your shoulders and back would hurt after a while. And then we also had the exercise bike. Again, a little different. No seat, no handlebars. Just strap yourself to the frame, pedal away. And you would sweat into orbit. Yeah. Again, the fluid dynamics is a little different in space. This is all science. So since we were actually quite interested in fluid dynamics, we came up with a couple ideas ourselves. One to make, of course, a really big ball of water. And just have fun with that. But then the other idea was to take a GoPro camera and put it into the ball of water and see what it looks like. We also put a little Alka-Seltzer tablet in the water too, just to make it a little fizzy, just to see what that would do. So here's the GoPro view. I think it's a little shagadelic.
That's pretty cool.
And one of the interesting things I found with the whole fluid dynamics is how I can point the camera a certain direction, so I not very smartly put my finger into the water to try to grab the camera. So from then on, I could not give a finger away. So it ended up crawling up my arm. And we wouldn't enjoy ourselves at all. Remember, this was science. Well, we thought that was such a good idea. We came up with another one. And we volunteered Alex due to his lack of hair on his head. Oh, sorry.
Yeah, so we basically wasted an entire Saturday off just playing with water. And we wanted to know if we could bounce water bubbles off each other. And it turns out you can. Off of surface tension. If you hit the bubble of water a little too hard, the water would combine and make it bigger. And if you hit it just right, your water would just bounce off. And Alex had floated by like a minute before me and grabbed the camera. He's like, hey, this is pretty close to a shower. We hadn't showered in about 100 days there, so we were loving the water experiments. Then you can take the syringe and inject more water in. And you can also pull some air in the syringe and put a water bubble in there, so that's or an air bubble. So that's an air bubble going inside of a water bubble. Which
Wow.
I thought would make it pop, but it didn't. And so it actually works as a lens. You can, from time to time, you can see my face in an air pocket inside the water pocket. You can bounce the air bubble off the insides of the water bubble. It's pretty amazing. But then it's why you say we had to put a human in the water bubble, and then And what we learned from this was Luca, the previous year, had the water intrusion in his EVA helmet, and we just didn't really know that much about. We 4 months with those guys, and we love our time with them. But at some point, they got to go home.
And so we did. And it's about 3.5 hours from the time you undock until you land. Once you hit the Earth's atmosphere, you get the plasma filled up. You get about 4.5 Gs. And then we also see the pieces of the heat shield coming off as it would slough off. And then we hit the ground with a little bit of a jolt. Not too bad. And we were on the ground, and again, quite happy. It was a nice feeling to be back on Earth. It was a beautiful morning in Kazakhstan. about 40 degrees out, very dry. It felt like a cool, crisp morning in the mountains. Of course, it was the middle of nowhere, but that's a good thing, I guess, when you're landing a capsule. And then it was off to 41.
And the main 41 was only about 45 days long, but we worked all 45 of those things without a break. And the first thing really was Alex and I got to go outside as two rookies and do an
The thing
EVA.
that I will remember the most about yesterday is the very first impression I had is I opened the hatch just the way I was